Okay, this video we will discuss how to simplify radicals. All right, and the questions we have are: number one, they're dealing with cube root here, and number two, we got a couple of fifth root. All right. Okay, and here I'm assuming that you have the basic knowledge of radicals, how it is the inverse of the exponent. Okay. All right, so let's begin. Let me erase these. Okay. It's not erasing, sorry. Okay. All right, so number one, as you can see, it's a cube root of that long radicand. And some of you may say, hey, you can't have a negative inside a radical. Well, that's true only if the index of radical is even, which in this case is not, it's odd. If the index of radical is odd, like 3 or 5 or 7, then it is okay to have a negative radicand like negative 24. All right? Okay, so let's begin. And what I'm looking for here are which part of this radicand, the negative 24x squared y to the 9 z to the 13th, is perfect cube. Cube because we're dealing with cube root. Okay? All right, and the way I do this is I'm going to split this cube root into two parts. First part is perfect cube, and second part I'll have some what I call leftover. Okay, so let's go this one at a time. Negative 24 is equal to, I'm going to use negative 8 times, actually 3 is better. Negative 3 times 8. Why 8? Because 8 here is perfect cube, 2 cube. All right, so the negative 24 is going to be written as 2 cube. So actually it'll be better to put negative 2 cube times 3. Okay, or this is same as a negative 2 cube times 3. It's the same thing. All right, doesn't really matter where you put the negative. But in this case, I chose to put the negative 2 inside the parentheses, the first parentheses. Okay, so hope you agree that negative 2 cubed, which is negative 8, times 3 is equal to negative 24. Okay, next factor is x squared. Well, x squared cannot go into perfect cube, so it can only go into so-called leftover factor. Okay, and y to the 9th, I know y to the 9th is y cube whole thing cube. So I'm going to write that as y cube whole thing cube, and nothing goes on inside that leftover factor. Z to the 13th, I'm going to write it as z to the 12th times z. Why 12? 12 because this 12 is 4 times 3. Multiples of 3 is really the key here. So I'm going to write z to the 13th as z to the 4th whole thing cube. That gives me the z to the 12th. Oops, I erased too much. Okay, and what's left is one more z. All right, so you can verify if I factored my original radicand properly. Okay, and of course that's really the main part of this problem. Once that is done, then I can write this as, I'm going to split this into two parts. And cube root of 3x squared z. Okay, and of course the first radical, the cube and the cube root, kind of erase each other out. Okay, the radical and exponent, they are so-called the inverse operation. So I just end up with negative 2y cubed z to the 4th times cube root, of course 3x squared z, that remains inside the radical. Okay, and that is our final result for this problem number 1 right here. Okay, now it is okay if you put the negative inside the radical, but some teachers may kind of frown upon that. Okay, all right, so let's do the number 2 problem. Actually, number 2 problem looks longer, but it's actually shorter. Okay, we have two separate fifth root in this problem, and you really can't do anything for each fifth root. Here, all the exponents like 1, 3, 3, they are less than 5, so not much you can do. Second one, you could a little bit because this 7 exponent is bigger than 5. But we're not going to approach that way. Okay, what we're going to do is we're going to rewrite this as one big fifth root. Just multiply the two radicands. You can do that if we have the two radicals with the same index. So it's going to be x to the fifth, because it's 1 plus 4. Y will be 3 plus 7, so it'll be 10. And z will be 3 plus 4, it'll be 7. All right. And that's what we have now. Okay. And if you look at this carefully, these two are nice exponents. Hope you can see why. Okay. Anytime you have exponent inside the radical that is a multiple of the index of radical, then those are so-called the nice ones. Z to the seventh, this is not so nice. Okay. So let's go ahead and simplify this the same way how I did the first problem. I'm going to split this into two parts, okay, where one part is perfect fifth power. And hope you can see that all of x will go in there, because what I have is x to the fifth, x whole thing raised to the fifth power. Y to the 10th will be y squared whole thing to the fifth power. Z to the 7th, this is z to the 7th, I'm going to write it as z to the 5th times z squared. So it'll be z, that's z to the 5th, and z squared. All right, and I'm almost done here. So this will be xy squared z. Again, anything under this perfect fifth power and inside the radical of fifth root, everything in the parentheses will be outside the radical, and this leftover will be inside the radical. All right, and this is it. All right, okay, and that's it for